In the series of videos on Laplace transform, today we are going to study change of scale property. Accordingly, if Laplace transform of function ft is phi of s, then Laplace transform of f of at is 1 upon a by s upon a. What we see here is when this t is multiplied by a scalar a, then its Laplace transform is divided by this scalar and this s is replaced by this s upon a. Simple. If you remember this, you can apply change of scale property to solve problems on Laplace transform. Let us learn how to apply this property. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Now let us prove this change of scale property. Laplace transform of f of at is 1 upon a phi of s upon a. Now by definition we have Laplace transform of f of at is definite integral from 0 to infinity e raised to minus st into f of at dt. In order to solve this definite integral, we will substitute u equals this at, so t will be u upon a, dt will be 1 upon a du. And the change in limits of integration, when t is 0, u is 0, and when t is infinity, u is also infinity. So there is no change in the limits of integration. So Laplace transform of f of at will be definite integral from 0 to infinity e raised to minus s into u upon a into f of u into this 1 upon a du, which is 1 upon a integral from 0 to infinity e raised to minus s upon a into u fu du. So we get Laplace transform of f of at equals 1 upon a into, for this definite integral, we write phi of this s upon a. This is how change of scale property comes into being. If Laplace transform of ft is 2s upon s square plus 4, we have to find Laplace transform of f of 2t. According to above rule, this will be 1 upon 2 into 2, and replacing this s by s upon 2 upon s upon 2 whole square plus 4. Cancelling this 2, it is half s upon s square upon 4 plus 4, that will be half 4s upon s square plus 16, which will be 2s upon s square plus 16. So this is Laplace transform of f of 2t by applying this change of scale property. If Laplace transform of f of t is 1 upon s e raised to minus 1 upon s, we have to find Laplace transform of f of 3t. So Laplace transform of f of 3t will be, according to above change of scale property, this will be 1 upon this 3 into replacing this s by s upon 3, it will be 1 upon s upon 3 into e raised to minus 1 upon s upon 3. This is 1 upon 3 into 3 upon s into e raised to minus 3 upon s. Cancelling this 3, this will be 1 upon s e raised to minus 3 upon s. If Laplace transform of 1 upon square root pi t is 1 upon square root s, we have to find Laplace transform of square root of pi upon t. Here we will try to express this square root of pi upon t in terms of some scalar multiple of this 1 upon square root pi t. So we write Laplace transform of square root of pi upon t equals Laplace transform of pi times 1 upon square root of pi t. According to above change of scale property, we write 1 upon pi into, we will replace this s by s upon pi. So this will be 1 upon square root of s upon pi, which is 1 upon pi into square root of pi upon square root of s, which will be 1 upon square root of pi s. Laplace transform of error function square root t is 1 upon s into square root of s plus 1. We have to find integral from 0 to infinity e raised to minus 3t error function to square root of t dt. We have, by change of scale property, Laplace transform of f of at equals 1 upon a pi s upon a. Therefore, Laplace transform of this error function we have to write as L of ERF. We will take this 2 inside square root, so that will become square root of 4t. We have to do this because in the change of scale property here, this a should be coefficient of t and not coefficient of root t, etc. So here a will be 4 and not 2. So this further becomes, by change of scale property here, 1 upon 4 into, using this 1 upon s upon 4 square root of s upon 4 plus 1. This will be 1 upon 4 into 4 upon s square root s plus 4 into square root of 4, 2 in the numerator. Cancelling 4, this will be 2 upon s square root s plus 4, which will be 2 upon, putting s equals this 3, it will be 3 square root 3 plus 4, which is 2 upon 3 square root 7. A similar problem, Laplace transform of ERF complementary, that is complementary error function root t, is 1 upon square root of s plus 1 plus 1. We have to find Laplace transform of complementary error function ERF c to square root of t. Laplace transform of complementary error function ERF c to square root of t will be Laplace transform of ERF c. We have to take this 2 inside the square root sign, so that will become square root of 4t. So remember here, a in this case will be 4 and not this 2. So by change of scale property, this will be 1 upon 4 into, from this 1 upon square root of s upon 4 as required plus 1 plus 1, which is 1 upon 4, 1 upon square root of s plus 4 upon square root of this 4, 2 plus 1, which will be 1 upon 4 into this LCM 2 up here upon s plus 4 plus 2 ones are 2. So this finally becomes 2 ones are 2 twos are 1 upon 2 square root of s plus 4 plus 2 twos are 4. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.